All right. Good afternoon, everyone. Final talk of the day. So just a final 30 minutes more, and then good to go home. So today I want to talk to you about how we can go from LLMs to Solana ecosystem agents. So this is quite a mouthful. So in the next 20 minutes or so, I hope to break it down into more digestible chunks so it makes sense what I'm talking about. Just to very briefly introduce myself, I'm Vatsal, the CTO of Apta, and we're developing Satoshi. So Satoshi is meant to be this kind of one-point access for all your crypto needs. You can use natural language to get various crypto insights. So you can kind of think of it as like the ChatGPT, but for crypto. And my plan for this presentation is for you to understand the technical side of how Satoshi is built. How are we able to extend LLMs using what we call Solana ecosystem agents? So especially in this world, there's a lot of confusion in terms of terminology. So I want to make sure we go as clearly and simply as possible so that we all follow along. So just to go through the scope of what we're going to talk about today, I'm going to start with the background of LLMs. Many of you will already be familiar with the history of natural language processing, but I just want to make sure we're all on the same page and we cover the basics of how LLMs have come to be today for generative AI. Then I'm going to talk about the current paradigm that's being used by all the big generative AI companies. So we like ChatGPT, Claude, Gemini. They all do something we call agentic flow. They elevate the power of LLMs. So we'll touch upon how this is possible. After that, I want to go on to actually say, okay, that's great, agentic flow with LLMs, but it's not actually sufficient when you want to apply to specific domains. So that's how I will motivate why we have Satoshi when you want to make agentic flow with LLMs applied specifically to the domain of crypto. Okay, so before we go into the background, I would like to perhaps toot my own trumpet a little bit and introduce you to our founding team, the technical founding team. So our expertise, I would say, is world class, as we all have PhDs from the University of Cambridge and have all done very well academically in the past. Specifically me, Vatsal, I have a twin brother, Vias. It's not just the same picture. And Adrian, we did it at the Machine Intelligence Laboratory, our PhDs in AI, before ChatGPT was a hype. So we were building GPT-style models from scratch long before the common person knew what an LLM was. And the reason I want to emphasize that is because when you understand the mathematics and the underlying technicalities of how these models work and function, you can actually do genuine innovation in building future models beyond just using wrappers around off-the-shelf solutions. So this will touch upon later into how our architecture works. Beyond our academic experience, we also have had experience working at some of the big tech companies in the area. For example, I was at the language understanding and relevance team at Meta in London, where I was researching something called efficient retrieval augmented text embeddings. An embedding is just a mathematical vector representation of text, but I won't go into the details of that right now. My brother, Vias, he was out in San Francisco researching with AWS Amazon, where he was looking at model robustness. So things like adversarial attacks, adversarial robustness. Basically, how do we protect these deep learning models from malicious abuse? And finally, Sharom, our CEO, he was a consultant at McKinsey. But besides our academic experience working in big tech, we have also had some experience working and building AI solutions for a wide variety of different companies. This includes, for example, AI native companies such as Sambanova and Chai, other companies looking to bring AI into their enterprises, such as the NHS, the Asian site, and various others, as well as AI investors such as Dawn Capital, where we did the AI due diligence for them. So really what I'm trying to emphasize from all of this is not just show off, but try and set the premise that we do know what we're doing and we are the right people to be developing the ChatGPT for crypto. Okay, that's enough of our background. Let's get back onto looking at what is the history behind LLMs. So in generating our modern day large language models, there are fundamentally really just two steps. There's pre-training and there's instruction tuning. But before we got to pre-trained LLMs, there was a bit of history for NLP itself. Back in the 1960s was when the first neural network was proposed. But more theoretically, at the time, there wasn't the compute or the data to actually make it applicable and useful in real-world applications. Fast forwarding to the 2000s, that's when deep learning kind of resurfaced. We now have the data and compute to actually make useful deep learning models, which were based on this neural network architecture. And then over the next few years after that, these deep learning models began to be applied in very bespoke manners to various applications, including natural language processing, which is basically anything to do with text. And this whole paradigm was that everyone would uniquely train a separate model with a different architecture for every natural language processing task, like question answering, summarization. But that all changed in 2017, when I think in the Attention is All You Need paper by Vaswani, he introduced this transformer architecture, which is a specific kind of deep learning architecture, which meant that it didn't need to rely on various bespoke model architectures, but everyone could build the models based on just this transformer. And then what Google did in 2018 was take this transformer architecture and apply a type of pre-training strategy to train basically on all textual data they could get their hands on. At the time, it was the Wikipedia data. And then after 2018, there was basically a huge race of producing AI models by all the big tech companies, such as we all know, T5, Roberta, Albert, and of course, GPT-3 itself in 2020. But these are the pre-trained LLMs. And the way they were actually trained was when you give it a certain sentence, all they have to do is kind of say what is the next most likely word given the sequence of previous words. And by training these models on a huge wealth of number of sentences, they gain a strong grasp of language. But at the point of pre-training, they're not actually particularly useful. They can't follow instructions. They can't do general tasks. They just understand language very well. So, which is why we needed the second stage, which is called instruction-tuned LLMs. So instruction-tuned LLMs took a pre-trained language model and then fine-tuned it on a varied number of instruction tuning datasets. This instruction tuning dataset consists of a multitude of different tasks, like translate to Turkish, or summarize this paragraph, or rewrite this poem in this style. And by training on a varied number of tasks, these LLMs gain what we call generalist capabilities, which we all are very familiar with today. When you ask ChatGPT, it's very unlikely when you ask it to write your haiku, it was trained to write haikus. But because it's experienced such a varied number of tasks, it's gained these generalist capabilities to perform tasks it had not done at training time. Okay, so that's where we are right now. There's ChatGPT, GPT-4, Llama, Mistral, everyone knows. Everyone kind of picks and chooses and argues which one is the best in today's state. So that's what we mean by instruction-tuned LLMs. But when you interact with ChatGPT today, it doesn't just use these an instruction-tuned LLM model. They go further than that. They do something we call agentic flow. And the reason for that is simple. There's certain limitations if you try and use traditional instruction-tuned LLMs right outside the box without using any agentic functions at all. And traditionally, they were designed just for textual data, sequential text data, which means if you have other kinds of modalities which are relevant in enterprises, these modalities might include unstructured, large structured databases, which you might want to query over, numerical data, charts and diagrams, or even multimodal forms of data such as visual information or visual aids. These models were not natively designed to handle such data. The other bigger, downside of these instruction-tuned LLMs natively, that they were not designed to perform reasoning. All they were really trained to do was, given a history of words, predict what is the most next likely word that they should predict. This is not inherently designed to do logic. So to overcome this issue, kind of as a community, what everyone does now, the biggest players in the field at least, is do something they call agentic flow. And to understand what is agentic flow to elevate the power of LLMs, I want to take you through a simple example. So what the high-level idea is that instead of having an instruction-tuned LLM doing everything itself, it's actually part of a greater ecosystem. And what I mean by that is we all recognize that the LLM is excellent communicator, is very good at language. It can very cohesively write different things and understand what you're talking about. But it can't, as we discussed, actually do reasoning or logic or understand what's the correct way of answering certain questions. So to be able to handle this issue, the LLM now just acts as what we say is the ears and the mouth of our system. It listens to what you're saying and it writes the final answer, but it is not the brain. So if we have a question, let's say, for example, I type into ChatGPT, or let's say it's an instruction-tuned LLM with external agents available, what is the weather today? This will be ingested by the LLM, but it does not respond. It passes to this agentic system, basically decides what are external tools or functions that need to be triggered to be able to answer this question. In this case, it decides we need two agents. Agent 1 is location identification, and agent 2 is weather database reader. So agent 1 basically looks maybe like your IP or MAC address and returns your longitude and latitude. This information is then passed on to the second agent, the weather database reader, which takes that information, passes that to some kind of API, which reads some weather database and returns that information in some ugly JSON format. So the agents have kind of done the heavy lifting. They've done the brain work of the system. And this output from the final agent is then given back to the LLM. And the LLM, now acting as a mouth of the system, says, okay, I know the original question. I know the responses from the agents. Let me just formulate the answer in a nice way back to the user. And hey, we get the final answer we want. The weather in Istanbul today is sunny with clear skies and a max temperature of 17 degrees, which somehow actually looks about correct for today. So that's the high-level idea of how agentic flow works, and this is what I would say is the current paradigm used everywhere. But that's not where we stop, because the main point is that there are still certain limitations for agentic flow powered by LLMs when you want to apply such architectures to very niche domains or very vertical specific cases. So what are those limitations? So let's consider off-the-shelf model. An off-the-shelf model, a generative AI model, will have access to only what I call generic agents. Some of these generic agents include, for example, a web search agent. Another example which is capable of searching the web to be updated about live information. So if you ask a question like, who is the president of the US, it's not using its training data anymore. It's triggering a web search agent to identify the live answer and feeding that back to the LLM. They will also have access to, for example, a Python coding agent. So if you ask a programming question or a question which needs to be numerically solved, rather than trying to answer directly from the LLM, it will trigger, for example, a Python code agent to write code to execute to answer your question. And various other kind of agents can exist. For example, multimodal agents such as file upload and image analysis. So you are no longer restricted to textual data, as we're all very familiar with that. But unfortunately, all of these agents are very general. And when you want to operate in a very niche specific domain, sometimes this is not sufficient. So we kind of break this down to three main limitations. First, there is a lack of access to specialized agents. You don't have agent targeted for your specific domain. Second, there's a lack of access to domain-specific data. There's a lot of data in your specific domain you expect the system to be familiar with, but general systems will not natively be familiar with your kind of data, or more often, you won't even have access to the data, because the data tends to be proprietary, hidden behind firewalls, or behind certain company enterprise systems, behind paid API services. But now let's imagine you do have a utopia, where we have this amazing generic system, which has access to every single possible agent in the world that we can think of, and also every single possible data source. But if we try to use this system straight out of the box for a very complicated task, we want to actually derive a deep insight in a specific domain, the latency will be too high. And I'd just like to walk you through a simple example to explain that. Consider you are in the, let's say, centralized finance space, and you care about investments related to specific stocks. The question I might want to type into the system, what are the attributes of US stocks that have performed the best in August 2024? Okay, let's try and break it down how a generic agentic flow system might try and tackle this question. It recognizes you are asking about US stocks and the historical prices. So what it does is first it needs to access this data. It uses some kind of data API about stock data from the US. For every single stock, collects the price information historically, or what it has been, filters it for August 2024, and now it has this data. Next, it has to think, okay, you asked for what are the best performing. Now, this is a very ambiguous term. You suddenly now have to define what do we even mean by best. So now it has to use some kind of agent which comes up with an algorithm of what it deems to be best in this space. And this complicated algorithm can consider various different factors, as looking at long-term risk, short-term risk, what actually happened in reality. So basically a bunch of different things that need to be considered to determine what is best. Once it's defined what is the algorithm metric to measure to define best, it has to apply this to every single stock. After applying to every single stock, you have to rank all these stocks. So even if you have this super powerful system, which could do all of this, which it can't, it will take way, way too long for you to actually get your answer. So if you had something which is actually domain specific, you could get that answer in the matter of seconds rather than the matter of hours. So at Apta, which we're doing for Satoshi, we try and address these challenges head on. We try and build domain specific, what we call copilots, or the ChatGPT for that domain, by building domain specific agents, giving domain specific data. And finally, this, I guess, our edge is we introduce something we call the preemptive agentic architecture, which does the heavy lifting in the background behind the scenes. So if you try and ask complex analyses of types of questions, that you can still get the answer in a matter of seconds rather waiting for a long processing time. And the reason the third one is possible is because you've targeted a specific domain. You know what people care about. You know the kind of analyses people are interested in. So you can pre-compute that kind of analysis behind the scenes and provide to them very easily. So that, I think, really is the magic in terms of user experience and seeing how you can get very complex, seemingly complex answers very, very quickly. Okay, so let's actually talk about Satoshi now. So Satoshi kind of leverages this whole technology stack that I described. We have the LLM connected with agents and domain-specific data. But to understand Satoshi, we have 3 layers in total. In Satoshi, we first have this, what we call the LLM layer. The LLM layer is the one which, as we said before, is the ears and the mouth of our system. Then we have our agent layer. This agent layer consists of very domain-specific agents. Each agent is designed for a very niche purpose. For example, an agent could be an influencer validator. Another agent could be a Twitter sentiment extractor. Another one could be a market history extractor. As you can imagine, very, very specific types of agents that can exist. And finally, our third layer is the domain-specific data. In this case, it's the crypto data on which the agents operate. So if I ask a question like, is Pepe up? It's a very simple question. What happens in our system? This goes to the LLM. The LLM, of course, cannot answer. It doesn't natively know the answer to the live price information right now. So it decides, I'm going to trigger the live market agent. The live market agent interacts with the live data being stored in our data layer to write some kind of query, structured query, to extract that information and send that back to the layer, to our LLM, which acts as the combiner and then presents that answer back to the user. And this way is a very simple example here. You can construct far more complex questions, which are just going to be routed to the appropriate agents to be able to answer the user's query. So the magic of this system, I would say, is very scalable. As we want to build new features and new applications, we can keep growing this to different types of applications of interests that a user base might have. But rather than me rambling on about example agents that we might have, I think it's easier to just show a slice of the type of features or questions that we can answer. So let's hope this plays. Amazing. So let's consider the question that I'm typing here. It might be a bit small, so I'll read it out at the same time. Imagine someone says, which meme coins are more than 80% down from the all-time high and have a market cap of at least 100 million USD? So you can see this is kind of like a complex filtering type question someone might want to ask, which will not work well in, let's say, a generic agentic system. And it's pretty complicated. But now what's happening here is the question has gone to our router LLM and it's deciding, okay, which agent is relevant to answer this question. It routes it to that agent, and that agent does all the processing and heavy lifting. And as here you can see, at the time this was run, I think a few days ago, it managed to outline all the different tokens and then outline additional information about those tokens that we want to present. You can click on, for example, these coin reports and see further information, for example, historically, or what it looks like. And just looking by eye, it does look like it's 80% down from the all-time high, as we can see, based on the y-axis. Okay, another functionality you might want to try, what's the news about one of these tokens? We saw Floki came up there, so let me try and ask more about Floki. Is there any news about Floki? I want as much up-to-date information about Floki as possible. So now the news expert is triggered, the news agent, and this returns information from the web. As we can see, there's references provided to all the news articles is found, and also to a Twitter agent. So you can see this final part being generated here is referring to his recent tweets in the last day at the point this was run that discuss Floki in the news. So trying to be as comprehensive as possible. It's trying to give you information from the web and also from Twitter. So we can even see the Twitter sources very easily directly in the chat, which mentioned this information. And then you can easily scroll through and read all the information in one place. You don't have to scatter your research for crypto research to lots of different platforms. You can just use this single platform to find everything you want. And the Twitter agent goes further. So the next question we're asking here, which coins have had the most increase in mentions on Twitter today? This, of course, is a coin you can expect to be of somewhat interest. So as expected, the most mentioned coin will be Bitcoin, as that's the most prominent by nature. But as you can see a ranking, what other coins are people talking about at the time on Twitter? Once again, it's very interesting for a simple user to very quickly identify what might be the mind share of the community, what is of interest to a lot of people. Another simple question someone could ask, should I buy Bitcoin? At this point, what we do is provide them like in-depth technical analysis. So a lot of trader type of people use things like RSI, MACD, Bollinger Bands to answer these questions. So here we've triggered, for example, the technical analysis agent underneath the hood, which once again could have done all this in the preemptive way. It's already done the calculation and the hard work. And it just has to quickly fetch this information back to the user when they ask it in natural language. And so that, I hope, the main thing to take away from this is we made a very modularized system which can handle a large, broad number of questions because we bespokely design each agent to every feature we think a user can cater for. So as we identify more and more features that people care about, we can continue to grow and comprehensively cover a variety of different data sources and needs and analyses that are of interest to the community. So that was just a snapshot of some of the features we have, but I want to quickly show you a roadmap of what other features are coming up into our system and what we think are of interest. So very soon, within actually next couple of weeks, we expect to have, for example, a portfolio assistant and investment dashboard assistant. So this will give you far more analysis and metrics across various different types of sources of what coins or analyses about those coins might be of interest when you're choosing whether to invest into a coin or not. We have calls backtesting. For each influencer, you might want to know how correct has the influencer been? You want to actually have the statistics behind this. How long do you have to wait till the average peak is reached? We have advanced on-chain capabilities. Can you identify from a certain token's on-chain behavior, whether it's been artificially pumping its trading volume because the same wallet is selling and buying multiple times? We can identify that naturally and give you those metrics when you search about the token. We're going to increase the user experience. Rather than chatting to it through text, you should be able to speak to it naturally, and you can have different personalities and speak back at you. So you can drive and use the system to do your research at the same time. We're going to integrate broader Web3 data. So we've been collecting data in the background from various different type of data sources, up to 4 petabytes. So all this 4 petabytes worth of data is going to be integrated into the system, which you can query over, once again, using natural language. Of course, additional blockchains. We focus initially on the Solana blockchain as well as other chains, and we'll continue to extend that. But what I'm excited about is the education agent. A lot of newbies coming into the field, they want to know how to use the system or to learn about crypto. These tutorials should be embedded directly into the system. They should be able to ask, okay, how do I make a trade? What should I do? There should be something directly in the system which guides the user how to perform these kind of actions. There's an execution agent, which can tell you things like, okay, can you buy Bitcoin when it hits 100K, sell when it hits 80K, for example? You just type that natural language, and the system once again is integrated into one place. So really emphasizing all your needs for crypto should be in one place only. You don't need to fragment your attention across lots of different platforms. But this final piece is the one I'm most excited about. It's what we call as a plugin for external agents. This is a bit more of a long-term vision. And the idea is that so far, all the agents that we have developed have been developed in-house. But in reality, if you want to be truly comprehensive and accessible for everyone and as useful as possible, we will never be able to access data from enterprises who don't want to give the data to us. There will always be a block for that. And the solution really is something which has become very popular in the AI communities, which is called MCP. And the idea being that Anthropic in November 2024 released this idea that there should be a standard for which LLMs communicate with agents. And if people follow this standard, it makes it far more seamless for these agents to communicate with the LLM when you want to scale to lots of different parties interacting with each other. So we really want to apply a very similar idea into the Satoshi ecosystem. Satoshi should have some standard defined so that anyone else can define their own agents that they want and interact with our system. And the two problems we're really tackling with this solution is that one is the fragmentation of protocols, By having one standard makes it very easy for people to design how you interface with our system. And the second bigger issue is privacy. Now people can maintain their agents and their data on their own servers. They run the processing on their own servers, and they just use the protocol to interact with our system. And the beauty is it's a win-win situation. So now it's still a one-point access for everyone. People can come to Satoshi and type in a question relevant to a third-party provider, but for the user experience, it's only asking one place. Underneath the hood, their query is being routed to that third-party provider's agent if it's relevant for that agent. And they win because they also access the traffic from Satoshi as well. So this is more of a long-term vision that I hope will enable our system to become incredibly comprehensive and cover various different needs. So hopefully I've been able to give you an idea of what we are doing at Satoshi. We are still developing every day. I think the project's come to a good place already. That's very useful for a lot of people. But there's also a lot of gaps. So we welcome any feedback from people using it. So I highly encourage people to actually try it out. It's completely free to use. You can use it as much as you want right now. And it's very useful for us if people actually give the genuine feedback or what they would find next very useful. Because so far, what we've decided which agents to build has been dictated internally by our team. But to go to the next step, we have to cater to our audience, the users. So we need to know what do people actually would use a system like this for. Why do you need to use natural language to answer certain type of research you might do when you're deciding what token to purchase in your day-to-day life? So I think that's it from my side, and thanks everyone for listening.